In this lesson, we're going to learn how to evaluate anomalies. So there are actually some problems when we do anomaly detection because we sometimes have to ask ourselves, how are we going to identify anomalies? And when these suspected points are identified, then how are we going to evaluate if they are really anomalies or not? So this lesson will give you more information about that. In evaluating anomalies, there are actually three things that we have to consider. The first one is that self versus self. Then number two is self versus others. And the third one is one member versus other members. So what does each of them all about? So in number one, we are actually just considering only one data point. I mean, one feature in a data. For example, we have date, and then we have temperature. Basically, what we do here is that we're going to identify on what particular date there would be a supposed anomaly. So in this case, what we're going to do is that we're going to compare each data point for all the dates given. That is why we are self versus self. It's because we are comparing the temperature with temperature, but of course, only for different dates. So that is self versus self. Another thing is that self versus others. So in this case, we're comparing one data point with other data points in our data set. For example, we have here Dan, and then we have here Grace, and here we have the spending of each individual for different dates. So for example, this is date 1, 2, 3, 4, and 5. And so, for example, we could see a trend like this for Dan and a trend like this for Grace. Okay, so we're going to add one more name here so it would be very much clear. Say, for example, we do have here Anne. And for Anne, for example, the trend is like this also. And as you could see, this is actually more or less in the case of Dan and Anne, they are similar, but in the case of Grace, at this particular part of our data, then there is some kind of anomaly. So in this case, we are not just comparing one entry, that is Dan, versus his own consumption or his own spending, but we're comparing Dan with that of Grace and Anne. So that is self versus others. Now, what if we are comparing one member versus other members? So in this particular case, we have clusters, and we are not considering here just only this kind of scenarios, but we are considering different populations for different clusters. So for example, here we have two clusters first, and then we have the second. As you could see, even if they are in only one data set, however, we could see that we have two clusters in our data. So that means this point here and this point here, although this can be considered part of this one and a part of the whole data set, it cannot be considered that as far as one is concerned, this one is a part of it, and we can associate the characteristics of this point with this point because this is a different cluster and this one is a different cluster. So in this case, what we are going to do is that we're going to observe the characteristics or behavior of these points in this cluster too, and we're going to study and evaluate whether or not this particular point here is really out of the characteristics of or behavior of these points here. We can also say the same story with respect to this point here. Okay. Our understanding of anomaly and fraud does not only stop just by doing the self versus self and number 2 and number 3 situations in this case, or the method of evaluation, but we also have to understand and to know that there are approaches in understanding anomalies. So we have actually tackled some of these things, but to give you better understanding, of course, we're going to have more of this one. And also in our future lessons, we're going to have mathematical calculations and even using Python how to identify anomalies. So the first approach is distance-based. So what is this? Just by the name itself, we are considering here distance. For example, we have here data points. So 1, 2, 3, 4, 5, 6, for example. And because it's distance, we are just going to consider the distance from this point to this point to this point to this point. So as far as these points are considered, then we can say that the distance of this point from the rest of the data points is actually very far. And because it's very far, then we can say that this one shows an anomalous behavior. And then we have density based. So what is this one? So as you can see in these data points here, we can say that the cluster can be found in here that are of low density. And in comparison to the more data points here, we can say that these points here are showing anomalous behavior. Now, the third one is the rank based. So in the rank based, what we do here is actually just by the name itself, we rank the data points. So what we consider here is the neighbors of the neighbors. So what do we mean by that? Very simple. For example, we have here a data point, and this data point here can be considered a neighbor of this neighbor or of this data point, and this can also be considered a neighbor of these points in here. So what we do here is that we basically compute which one is nearer to each other. So if this is nearer to this than this one, then we can say that these points here, including this point, can be considered not anomalous. But if this is farther from this point here, then, or nearer from this point in here than this one, then we can say that this is not considered to be anomalous. So we will be having more of the mathematical calculation of these things in our next lesson. Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free, like Machine Learning Essentials, Deep Learning Mathematics, and a lot more. Here, you can always learn an upskill for free.